Hello everyone, I welcome you all to Statup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we did some of the concepts on expectation in statistical methods, and in today's lecture, we'll move forward with the same expectation with some new laws and some new kind of questions. Let us see. So expectation also have one formula, which is covariance. If we have to find the covariance between two variables, then it can be expressed as expectation of x y minus expectation of x into expectation of y. And if the covariance is between two same variables, if we have to calculate the covariance between two same variable, it is nothing but variance of that variable. This is the very basic concept, and on them we'll do some questions today in class, and I'll while doing the question, I'll make you do the laws that are related to those questions. So this is the first question, in which it includes the concept of joint probability distribution function as well. So in this question, they have given us that x and y are jointly distributed with PDF. They have been provided as the joint distribution PDF, and they have asked us to calculate estimation of x equals to estimation of y. Means if we have to calculate the estimation of one variable out of two joint, then we have to calculate first of all that it has the integration x with x into fx dx, but this fx can be obtained from our joint probability function, as fx can be obtained as integration over y fxy dy. Integration is nothing but subtraction. If from joint PDF distribution, let us see here, if there is one joint box of x and y, both x and y are here present here. If I subtract this y from here, then I'll only be left with x. So that is what we are doing. If we integrate the joint distribution function with respect to y, then we'll only be left with the function of x. That's what we do here. So first of all, we have to calculate the marginal distribution function of x for calculation of estimation of x. So let us do that first. For calculating fx, it will be integration over y. Y has range 0 to 1. fxy, the joint distribution function is x plus y with dy. Then this can be written integrated as xy plus y square by 2 with the limit 0 and 1 of y. These are the limits of y. So if we put the limits, we'll be getting x plus 1 by 2. This is our function, the marginal function for x. And similarly, if we have to calculate the marginal function of y, it will be carried out with the same, but here we'll integrate it with respect to x, and it will be xy plus x square by 2, 0 to 1, which is y plus half. Now, since they have given us estimation of x is equals to estimation of y, we can take any of them. I am taking estimation of x. Estimation of x is nothing but integration x fx dx. Integration over x only. So, if we integrate x, fx is x plus 1 by 2 dx. Now, this can be written as x square plus x by 2 dx. If we integrate it, we'll be left with x cube by 3 plus x square by 4 with the limits 0 and 1. If we put the limits, it will be 1 by 3 plus 1 by 4, which is nothing but 7 upon 12. And hence our answer for this question is option number C, 7 upon 12. If you know the concept, you'll be able to solve it in examination. Now moving forward to the next question. This question here states covariance. if x and y are independent random variable and covariance between x and y is equals to, now I have told you covariance between two variables x and y is nothing but estimation of x y minus estimation of x into estimation of into expectation of y. So, since they have given us x and y are independent, and we have learnt a formula, then when x and y are independent, expectation of x and y can be written as expectation of x into expectation of y. This was in the previous lecture where I told you the rules of expectation. So now covariance of x and y can be written as expectation of x into expectation of y minus expectation of x into expectation of y, which is nothing but 0. And hence we get option number A as our correct option. This is one of the rules that they have asked directly. So instead of calculating it, you should just mug it up that when x and y are independent variables, random variables, then covariance between x and y is always 0. Now moving on to the next question, where we have been provided with a question. Here they have asked us that x and y are two random variables and they have given us what to calculate, where alpha, beta, gamma and delta are the constants. So covariance between ax plus beta into gamma y plus delta. If we have to calculate this, it will be covariance between ax comma gamma y plus covariance between beta comma gamma y plus covariance between ax comma delta plus covariance between beta comma delta. I have told we have taken every single this first covariance between these two terms, then these two terms, then these two terms, and then these two terms. So now if we see that here one is constant, here one is constant, here also both are constant. So covariance between a constant and a variable is always equals to 0, and between a constant and a constant is also equals to 0. So all of these three terms will be equal to 0. Now we are left with this covariance of ax and gamma y. This can be written as, if we take it into consideration, covariance of ax alpha x comma gamma y is nothing but we can take the constants outside alpha, gamma, and we are left with covariance between x and y. So this is our final answer, and which is also a rule, and hence our option number A is correct. This also you should mug it up. It is also a rule and they have asked us directly. You don't need to calculate all of this in examination. Now moving forward to another question. They have asked you, they have given us a uniform distribution with limits 0 and 1. Now, we all know that if we see here, this is a difficult question which haven't been performed by us before. So, the trick here is to use x1 plus x2 plus x3 upon x1 plus x2 plus x3 should be equal to expectation of 1, and expectation of a constant is a constant itself, so it should be equal to 1 because numerator and denominator will get cancelled. Now we can write it as expectation of x1 upon x1 plus x2 plus x3 plus expectation of x2 upon x1 plus x2 plus x3 plus expectation of x3 upon x1 plus x2 plus x3 equals to 1. We can write this term like this, and since we have proved it equal to 1, we can also write this. Now, since you can see that these are IID, independent, identical and independently distributed random variables. So x1 should be equal to x2 should be equal to x3. So here in place of x2 and x3, we can write it as x1 and x1 only, because all are same, identical. And here we can, hence we can write it as 3 into expectation of x1 upon x1 plus x2 plus x3 should be equal to 1. And if we divide it by 3 both sides, then it is equals to 1 by 3. Now they have asked us to calculate x1 plus x2. If we take it as expectation of x1 plus x1 plus x2 plus x3 plus expectation of x2, x1 plus x2 plus x3, this should be equal to, these are considered 1 only, so this should be equal to 2 into expectation of x1 upon x1 plus x2 plus x3. And if we multiply it by 2, the above equation, we'll be getting 2 upon 3, which is our option number C. Hence our option number C is correct. So this was the trick, and after that we can follow mathematically. You must have solved many of questions of these kind, but just their expectation was not there. So this is how we solve these kind of questions. Now moving forward to another question, which is one of the PYQs of our ISS examination. They have asked us the PDF. They have given us the joint PDF of x and y, and they have asked us to calculate the expectation of xy. Now we know that if we have to calculate expectation of x, then it should be integration over x fx dx. But if we have to calculate a expectation of xy, it will be double integration over x and y, xy f, and joint probability distribution. This will be the formula. Simple, as you can see. So expectation of xy is nothing but double integration, first of y, then of x, xy f joint distribution and dx dy. Now substituting the values only, the limits of y are 0 to 2, the limits of x are 0 to 1, xy 1 upon 3 x plus y dx dy. Now writing all the terms outside, all the constant terms outside, 0 to 2, y can be written here because y is considered as a constant there, and 0 to 1 x square plus xy dx in one bracket and dy. Now solving this, we will be getting 1 upon 3 integration 0 to 2 y. If we solve this, this will be x cube by 3 plus x square y by 2 with the limits 0 and 1. And if we put 0 and 1 in place of x, then we will be left with 1 by 3 plus y by 2, which is 1 by 3 plus y by 2. And instead of writing this, we can directly multiply it by y. It will become y by 3 plus y square by 2 dy. Now integrating this as well, we will be getting 1 by 3 y square by 6 plus y cube by 6 with the limit 0 and 2. If we put 2 and 0 as limit, outside it will become 1 upon 18. 4 plus 8 will be 12. And this will be nothing but 2 upon 3, which is our option number A. Many of them are coming 2 by 3 by chance. but this is how they follow in the examination. It was an easier one and it should be solved within a minute in the examination. Only if you know the integration and the how to attempt the question, it was easier one. Now let us move to another question. This is a bit difficult and this can be asked in your examination. So, this is based on covariance. They have given us the joint probability density function of x and y, and they have given us the limit as well. But here the limit is intertwined between x and y. They are not independently distributed, they are dependent on each other. And they have asked us to calculate covariance between x and y. Now for covariance, if we know the formula, covariance between x and y is nothing but expectation of xy minus expectation of x into expectation of y. So in here, in this question, we have to calculate expectation of xy, expectation of x, expectation of y. And this will become a bit difficult because when we calculate it, we have to also convert it into points, not even fractions. So I would suggest you in the examination, you can skip these kind of question for doing it later, so that you will be saving time. And uh, also, after even after at the end, if you are sure that you know the formula and you'll be able to do it within 2 to 3 minutes, then only attempt these questions. Otherwise, ignore them. They are just for wasting your time in the examination. So they have provided us with this. Now let us start with, first of all, expectation of xy. We know the formula. It is double integration xy into 8xy. Now I am directly putting the formula. First of all, let us put the limits of y, which is 0 and 1. And limits of x is nothing but y to 1. xy, fxy is nothing but 8. X square y square dx dy. This is it. So first of all, we can take x outside, 0 to 1, y square 8 integration y to 1 x square dx dy. If we solve this, it will be 8, 0 to 1, y square x cube by 3. It will be, integration will be x cube by 3 with the limits 1 and y. If we put the limits 1 and y, it will be 1 by 3 minus y cube by 3, or we can write it as 1 minus y cube by 3, and 3 we can take outside. So I am multiplying it 1, which is y cube y square minus y cube, which is y raised to the power 5 dy. If we multiply the outside y square as well. Now integrating this one, it will be 8 by 3 y cube by 3 minus y 6 by 6 with limit 0 and 1. So it will be nothing but 1 upon 3 minus 1 upon 6, which will be 1 upon 6 only. Let us see. 8 by 3, 1 upon 3 minus 1 upon 6. 6 minus 3 will be 6. 3 is 18. And 3 6 is 18. Here. 8 upon 3 into 1 upon 6. So this will be 4, this will be 3, and we'll be getting 4 by 9. So our expectation of xy is coming out to be 4 by 9. I have written it. Now we'll do expectation of x. So for calculating expectation of x, we know that the formula is nothing but integration over x fx dx, right? But for this we have to calculate x also, fx also. So how are we going to calculate that? First of all, we have to calculate fx. Instead of calculating it differently, we can calculate it here as well. If we put the limits of x is nothing but from 0 to 1 we are taking x into fx. Fx is nothing but integration over y, which is uh, 0 to x, and fxy, which is nothing but 8xy dy. Right? Now, instead of writing 8x inside, we can take it outside because it is only integration over, it is only integration over y. So we can put it like this: 8 integration 0 to 1 x square, and y, if integrated with this, it will be y square by 2. Now with the limit 0 and x, if we put the limits, we'll be getting x square by 2, and we can directly substitute it. It will be upon 2 will come outside, and it will be x raised to the power 4 dx. Dx will also come. So it will be 4 integration of x raised to the power 5 upon 5 with the limits 0 and 1, which will be nothing but 4 upon 5. So our estimation of x is nothing but 4 upon 5. 4 upon 5. We can write it here. Now similarly, we can proceed with estimation expectation of y. Expectation of y is nothing but integration over y f y dy, right? But since we don't know fy, first of all we'll take the limits of y. Y has the limit 0 and 1, and okay, outside we take the limits of numbers, and inside we can take the limits of variables as well. So y will be outside, and it will be fy will be limit of x, which is nothing, which is y to 1, fxy, which is 8xy dy, and whole dx, because we are calculating for y, and whole has dy. Now here also we can take outside 8y, outside 8 integration 0 to 1 y square integration of x. Integration of x will be x square by 2, which is nothing but 1 square minus y square by 2, and 2 we can take it outside dy. Now here also we can multiply it inside, and it will be y square minus y raised to the power 4. If we do this calculation as well, it will be y cube by 3 minus y raised to the 5 by 5 with the limit 0 and 1, which will be 5 minus 3 is 2, 8 upon 15. So our answer will be 8 upon 15. And hence it is nothing but 4 by 9 minus 4 8s are 32 upon 15 5s are 75. If we subtract both of them, we will be getting as, taking the LCM, it will be 225 100 minus, if we divide 45, 225 96, which is equals to 4 upon 225, and if we convert it into decimal, it will be 0.16, which is our option number B. So see, you can see yourself that how much this has taken your space, time and energy. And although we knew every concept, then also it was a difficult one. So I would suggest you all to ignore these kind of questions, because they have been put in the examination just to waste your time, so that you might not be able to score well. And half of this question, if have been asked, if they have asked us about this, they have also given us that we should multiply it by 9. So we have to multiply it by 9, then only we'll be getting this. This will be 45. 4 upon 45 will be 0.16. So they have asked us half of, if they asked us only calculating e raised to the power exy or ex or ey, then we can attempt them very easily. But the whole concept is a bit difficult for us to cover in an examination which has a short span of time. So this was all for today's class. I hope that I was able to make you understand the concept and the questions as well. If you're facing any doubt, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.
Startup Academy.